Hello everyone, this is Professor Robert Solis. Welcome to this next video lesson. Excuse me, we're going to talk about assembly language programming, but we also want to talk about this idea of jumping to different locations. We've already talked about labels. Well, what if I want to jump to this label or jump to that label? How would I do that? So first let me go ahead and create a C++ program because we're going to be working on inline assembly programs. And so this is Visual C++, Win32 console application. This is going to be CS242. We'll say assembly and lab 4. And we're going to make sure that this is an empty project. Now I can go ahead and create my C++ program by going to Solution Explorer. I'm going to right click on source files, add a new item. It's going to create a source.cpp. That's fine. So I'm going to click add. And of course I start off with include IOStream using namespace std int main system pause return 0. Okay. All right. So the idea is to ask the user to enter a whole number, and then once they enter that whole number, do I want to increment or do I want to decrement that whole number? And then we're going to have two separate labels that will either increment or decrement based on the user choice. So what I'll do is this. I'll say int num1. Now on my code I have int num2, but do I actually use that? I don't. So I'm not going to type int num2. Maybe I'll have to type it later on, but let's see here. Going on my notes here, I'll have a result, and then I have a choice, because I'm going to ask the user, press 1 if you want to increment, press 2 if you want to decrement, something like that. So let's go ahead and ask the user, enter a whole number, right? And we want to either increment or decrement that whole number. So I'm going to cin, I'm going to put that into let's see here. It looks like I'm putting that into result. Okay. Now, I will give the user a little menu system that looks like this. 1, increment. Go to the beginning of the next line. 2, decrement. Go to the beginning of the next line, and del. Cout, what do you want to do? So the user is either going to enter 1 or 2, and so we're going to cin that value and put it into the variable choice. So now that I know what the user wants to do, I can now go into the assembly level, inline assembly level program. So __ASM followed by an open and close curly braces. Okay. So the first thing that I want to do is to obtain the choice from the user, and then based on that choice go from there. So I will say MOV into the EAX register whatever the choice is that was entered by the user. Now I'm going to compare CMP. So CMP in assembly language programming is a comparison operator. What am I going to compare? I'm going to compare EAX to the number 1. Because if the user entered number 1, and if I do that comparison, and if I say, hey, if the comparison results in these two being equal, then do this. If the comparison results in something being unequal, then do something else. It's very similar to the if statement, right? So the compare, the CMP, and the jump, or JE if equal, or jump MP, or any of the jumps, it's kind of like an if statement, a selection structure. If this, then do this. But first in assembly, I have to perform a comparison. Now, if that comparison is equal, then I want you to jump to a label called increment label. Now, I haven't created increment label yet, so this is erroneous right now. What if that's not the case? What if these two are not equal? Because the user entered the number 2. See, I'm just asking, hey, did the user enter 1? we're going to do a comparison. If the user entered 1, then that means if they're equal, right, if this is equal to this, if the comparison results in being equal, then jump to this label. But what if that's not the case? Well, if that's not the case, did the user enter 2? Well, let's do a comparison. Is the EAX registered when I compare it to 2, is that equal? Because if that is the case, then I'm going to go to another label called decrement label, which again I haven't created yet. I am about to create, right? Now, if both of those comparisons are wrong, this is the unconditional jumping statement. I'm going to jump to a label called end of program, end of program label. Now, I'm putting the word label here since you are introductory students to assembly language, but if I were writing this program for myself, I might not put that word label there. I mean, it's good for readability, but you don't have to put that word label there. It's just an indication to you that there is a chunk of code for you to jump to. All right, well, let me work from the bottom up. First of all, I'm going to type in end of program label. This had better be the same spelling here as I spelled over here. So maybe I just take this, copy, paste. All right, so what this does is if this was not true, then for sure, unconditionally, you are going to jump to this label. What is at the end of this label? Nothing. So in essence, you have finished the code. Okay. Above that, I'm going to have decrement label. So I'll just simply take this guy over here, copy, paste, put a colon after that, and I'm going to hit tab. I want you to move into the EAX register whatever result is. Remember, the user enters a number. We ask the user to enter a whole number. We are either going to increment or decrement that whole number based on what the user wants to do. So the user entered a choice. So I've obtained that choice. Is the choice that the user entered 1? Because if so, go to here. Is the choice that the user entered 2? Because if so, go to here. Finally, if the user didn't enter any of those, then you're just simply go to the end of the program. Okay. So over here, I know now what the number is that was entered by the user. It's result. So now that I know that number, I'm going to move that into the EAX register. You know what the EAX register is like, and the same thing with the EBX and ECX and the E. They're like playgrounds or sandboxes, and I get to do stuff with them, and I get to manipulate them, and I can also see what's in those sandboxes. That's how you can think of it. All right, in this case now, what do I want to do if I'm going to decrement a label? Then I want to sub. Sub is a mnemonic for subtract by, in this case 1. Subtract by 2, subtract by 3. Well, in this case, if I'm decrementing, I want to subtract by 1. Well, once I've done that, then I'm going to move into the result variable whatever is inside of the EAX register. Because see what I did? I got the value. I subtracted it by 1. Now I'm going to put it right back into result because it's been updated. Specifically, it's been decremented. Isn't that what sub means? So in this case, we're going to be subtracting 1 from it. Now that I am finished with this code, I am going to unconditionally jump to a label called end of program label, which in other words means go from here and here. We're done with the program. Now, I also have the ability to jump to another label over here called increment label. So let me go ahead and paste that over here, colon. Now what am I supposed to do over here? Well, if I'm called, I'm supposed to increment the value by 1. So we'll say MOV, move into the EAX register, whatever is in result. Now, if you want me to increment, that means add. That's the mnemonic for addition. In this case, I'm going to take that EAX register and I'm going to add by 1 because that's what increment means, increase by 1. Once I'm done, I'm going to take the move mnemonic and I'm going to move into result whatever is inside of the EAX register. When I am done, I'm going to jump out, so JMP, that's the unconditional jump, and go straight into end of program label. All right, so here's a couple things that you've learned about, and we're going to run the code, and then I'm going to step by step through the code. You cannot jump unless you perform some sort of a comparison. That's what I want you to think of right now. You perform a comparison, and you jump based on the result of that comparison. In my case, I'm asking, did the user enter a number where this is equivalent to this? That's jump if equal. Well, jump if only EAX is equal to 1. If that's false, watch this. I go to here, and I perform another comparison. EAX, is that the same thing as the number 2? Let's perform a comparison. If they are equal, then you're going to jump to this label called decrement label. Finally, nothing happens if the number that you entered is not 1 or 2. If the number is 1, I'm going to jump if equal to increment label, which means I go from here to here. I take the number that was entered by the user, I increment it by 1, and now that new value, I put it right back into result, and now I jump to the end of the label, because if I didn't have this, it would execute this. We don't want that, so I got to jump out of this, right, so that it doesn't execute that code.
I have 2 quick questions. Can you only have one jump equal statement?
Nope, you have as many as you want.
Okay. And can you do operations, like math operations?
Absolutely, such as yeah, any mathematical operation. So on the first and second video, I think I showed multiplication, division, subtraction, addition, and I also showed modulus as well. Now, so far, all we've done is integer multiplication, right? Next time, we'll look at real number multiplication and division. All right, so if I'm done with this, then it's just simply send out whatever the result is. So we'll say the result is, or yeah, that's right, the result is, and then I can just simply send out whatever that variable name is, which in this case is result, and then end-del. I guess I could have said incrementing the value results in, or decrementing the value results in. Yeah. We can do that later, or you can do that later. Let's run the program, and let's just see it work first. So I enter the number 5. That's a whole number. Press enter. Increment or decrement. Okay, I'll push number 1 for increment. Enter. The result is 6. Okay, let me get rid of that space and put a space over here, but the operation is correct. So the result is, and then I'll put a space after that. Let's run the program again and test decrement. So I enter the number 5. 1 for increment, 2 for decrement. I'm going to number 2. The result is 4. Yep, looks good. All right, now let's stop the program and investigate what's going on. So let me stop it over here. Run the code. Ask the user to enter a whole number, the number 5. All right, what do you want to do? Let's say that we want to increment. All right, so we've frozen time right here. As you can see here, choice is the number 1 because we selected increment. We are about to move that into the EAX register, which contains garbage, right? Random number. So let me go ahead and step over. Now you see that EAX is 1. Let's perform a comparison. See these flags right here? Okay, let's perform a comparison. Let's compare EAX to the number 1. Okay, so I step over. All right, so it looks like that comparison is equal. Because that comparison is equal, watch what happens. So I'm going to step, and we go immediately, because they were equal, they go immediately to the increment label. All right, so what am I going to do in the increment label? Well, first I'm going to move it to EAX, whatever result is, which is 5. Let me add 1 to whatever is in EAX, so it's 5. Now it's 6. Let me move EAX back into result. Result is still 5. Now that we've incremented it, that's going to be 6. And then finally, let's jump to the end. So from here, notice I jump to the end, and there's nothing after that, so that just is going to be the cout statement, and that's why we see the result is, in this case, 6. Let's do it again for decrement, just so that we can be thorough. Let me enter the number 5, number 2 for decrement. We've just frozen time, so I'm going to obtain that choice. Is this EAX register, is it the number 1, or is it equivalent to the number 1? No, it's not. So notice what happens here. I go to the next comparison statement, because this was false. All right, how about this? Compare this with the number 2. All right, so we compare it to the number 2. Is the previous comparison Equivalent, yes it is. So we jump if equal to here. So we're going to jump over here to the decrement. We take the result, we move it into the EAX register, so now this becomes 5. We're going to sub EAX by 1. So this is 5, now it's 4. Then we're going to move EAX into result, which is currently 5, but now it's 4. And then finally we jump. So we're going to jump out, and then in this case we're just simply going to display the results. Since I decremented 5, the result is 4. And that's it. So what you learned is you can create labels for chunks of code that you want to generate. Notice that your last label is always going to be the one that jumps out of the program because it's going to have no code underneath it. And so that's why you use the unconditional jump. Could I go back? Yeah, I could. We typed in RET for our previous code for the previous video lesson. We could jump back to the calling program. In this case, I'm not going to be doing that. I'm going to be jumping out. Now, you'll also notice that JE is jump if this is equivalent or jump if it's equal. JMP is jump unconditionally. Before you do any of these, like jump if equal, jump if not equal, you're going to make sure to do a comparison, and that's CMP that does the comparison. Now, just for the sake of thoroughness, I went to this website over here. You can see that this is unixwiz.net/tech-tips/x86-jumps.html. x86 means Intel chips, and here are all of the various jump mnemonics that you have. We did this one over here, jump if equal. So what is it going to do? It's going to read that 0 flag, right? And if the 0 flag is true, then that means that it's equal. What about JNE? Jump if not equal. Well, guess what the 0 flag is? It's 0 in this particular case. How about jump if greater than, and so forth? So here you go. Jump if not below. Jump if above or equal to. So it's a little bit different than us C++ programmers. We tend to read like we say if it's greater than or equal to or less than or equal to. Well, here the wording is different. Here is jump if below as opposed to jump if less than, right? Over here, jump if not below or jump if above or equal to. We typically use the word greater and less than. But it's still the same idea, and here are the mnemonics that you would use. Jump if less, jump if above. Oh, here's one, jump if greater or equal to, JGE, and so forth and so on. So you could use these various flags for whatever operations you want. And that's it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.